Good evening all. So this is Maniramakrishna teaching about the current and current density. So first we'll talk about the current is defined as the rate of change of charge with respect to time. So current in the terms, the current is defined as the rate of change of charge with respect to time. That is I is equal to dq by dt. Here q is the charge and with respect to time. So that is change of charge with respect to time, that is dq by dt. The units are the amperes. Okay, as we know the I is equal to dq by dt, that is the units are the amperes. Now coming to the current density. So current density is that is equal to indicated with the J, that is I by S. So that is the current per unit area. So current per unit. So A cap. The A cap is the unit area, unit vector, that is where A cap is perpendicular to the area of surface A. So suppose if it is a conductor here and the current is flowing through this one. So the current is flowing in this direction, whatever the surface areas, that direction is perpendicular to the surface. Okay, the current direction is surface. Okay, that is I by S. So that is the current per unit area. So A cap is that is a unit vector with perpendicular to the area. Okay, this is about the current density. So here we having the three types of current densities, that is one is conduction, convection and displacement. So conduction, convection and the third one is displacement current density. So these are the three terms which relate to the current density. So we are talking about the first current density. So first we will talk about the conduction, convection and displacement. So this is about the displacement. So if we talk about the conduction, so conduction we can see in the conductors and convection we see in the vacuum tubes, and the whatever the displacement we can see in the dielectrical material. That is conduction is deal with the conductors, okay, and convection is with the insulators and vacuum tubes, and displacement we can see in the dielectrical material. That is these three types of current density we can talk about it. That is conduction, convection and displacement. Now coming to the topic current density. So current density having the three types, one is conduction, convection, displacement, current density. So first we'll talk about the conduction. So conduction is take place in the conductors. So whatever the heat will be developed, so the current will flow in through the conductor and heat will be developed, that will take place in the conduction. In coming to the convection, so convection is take place in the insulators. So in insulators where current doesn't involve, okay, that is conduction doesn't take place, but whatever that is, okay, so in the conduction, that is current will be involved with the conductors, okay. In the convection, current doesn't flow through the involved, okay. So conduction doesn't take places in this conduction, but that is will be applicable in the insulators, okay. So we can see in this in insulators. So insulators, if we take the example, the current, so if we take the vacuum tube, so in the vacuum tube beam of electrons is flowing through this one, okay. So the beam of electrons is flowing through the vacuum tube, that is in terms of convection. So as well as, so the current flow through the insulating medium, that will be not, okay. So this convection doesn't obey the Ohm's law, okay. So doesn't obey the Ohm's law, okay. This convection doesn't obey the Ohm's law. Next coming to the displacement current density. So this current displacement density, okay, displacement current density we can see in the dielectric mediums, okay. So we can see in the dielectrical medium, that is whatever the types of conductors are there, that is conductors, insulators, dielectrical medium. So we can see the first one is that in the conductors, so we can see the conduction. In the convection we can see in the insulators, and displacement current density we can see in the dielectrical medium. These are the three types of the current density. So we can talk about in the coming classes about the three types of current densities. Now coming to the topic, so relation between convection current density, volume charge density and velocity. Okay, so we are talking about the relation between the convection current density, volume charge density and velocity. So here we are indicating the J, that is current density, convection density, and the volume charge density with the rho v, and the velocity mu. So whatever we are taking, so you can take that. So if we are talking about this relation between the three things. Okay, so here we are considering the two axes and we are taking the one. Okay, so here whatever the volume is, so we are considering the one volume. So the volume length is there, we are indicating the L. So if the volume is moved certain movement, okay, in the x-axis direction, so the movement we are taking in the x-axis direction, that is whatever the volume is, that is moved at distance, that is we are considering the, that is del x. Okay, so we are considering the one distance, that is x. Okay, so the current distance we are moved, that is movement, the volume is distance. So whatever the surface is there, this is the surface volume, so that is moved at the distance x. Okay, so that index. Okay, so distance is moved. So here whatever the inside is, okay, so what inside the volume is there, okay, present in that, that is flowing through this one. Okay, so whatever the current density, that is flowing through this direction. Okay, so here we are direction, that is we are talking the inside. Okay, so inside the box, rho v, that is the value, that is the rho v. Here the volume current density, whatever current, so the volume charge density, so volume charge density rho v is, okay, so rho v is present and moving. Okay, so present and moving in the x direction, moving in the x direction. Okay, so moving, whatever the rho is placed, that is moving along the x direction at the distance del x. Okay, so here in a small time, okay, so we are considering that in a small time, in the small time del t, the current has moved. Okay, the current has moved at the distance. Okay, well, how much distance? That is del x. Okay, whatever constant, that is distance is del x. So here whatever the charge moved, okay, so here we are counting the whatever the charge done, so that charge moved, okay, we are indicating the del q. Okay, so del q is equal to rho v, okay, into volume. Okay, so whatever the volume is that, so volume charge into the volume. So here the rho v into volume, so we are indicating the change in, okay, so change in charge, that is equal to rho v into s, that's indicating the whatever the surface is there, that indicating with the s, and the distance, okay, indicating the x. Okay, so here we are talking this. So now if you are taking the both sides, okay, so we are taking the both sides dividing, okay, both sides dividing with the del. Okay, so if we are both sides is dividing with the del t, so what we have? So let us see. Now coming to this one, so here, so what we are taking, so we are dividing with the both sides with the del t. Okay, so we are dividing the both sides with the del t, so they will get the charge, rate of charge by time. Okay, that will get with the I. Okay, rate of charge, that will get in the I. So the current, and here indicates the velocity. So the velocity change displacement type time, so indicating the velocity ux, and that is x means the direction which is flowing the direction, that is x direction, that's why velocity taking the ux. Okay, so I by s, so we are taking the this side by s, surface I by s, so here rho v into ux. Okay, so rho v into ux. So then will the I by s, that is the current density, current by area, so indicating with the j. Okay, j is equal to rho v into ux. Okay, so we can write as a j is equal to rho v into ux. So this is the relation between the current density, volume charge and velocity. Okay, so current density, volume charge and velocity. Okay, this is the relation between this one. Okay, so here in the next we are going to, that is current continuity equation. Okay, in the next class we can talk about the current continuity equation. Thank you.